Ancient Sumer, when you look at their tablets and like what are they saying, and why would they dedicate so much time to talking about this stuff? Why do they have pictures of giant, enormous people-looking things?
If you look at the night sky, you see one moon. But 4,000 years ago, an ancient scribe etched a record into clay about a second celestial visitor. It hung above the earth, defied the path of the stars, and then vanished without a trace. Did the people of the ancient world truly witness a second moon? The tablet nobody could read. There is a clay tablet sitting in the British Museum right now, and it has been there for over 150 years. Scholars from all over the world have examined it, argued about it, and walked away more confused than when they arrived. Not because the writing was damaged or the language was unknown. The script is perfectly readable cuneiform, a system specialists have understood for well over a century. The problem was something far stranger than a translation issue. Nobody could agree on what the scribe was actually describing or why this particular tablet was unlike the tens of thousands of others in the same collection. The tablet carries catalog number K.8538, and it goes by the name the planisphere. It is circular, which is already unusual, since most cuneiform tablets are flat rectangular slabs of baked clay used for grain records, tax lists, and contracts. This one is round, covered in constellation drawings, and packed with astronomical observations that resisted every serious attempt at a convincing explanation for generations. It was found in the 19th century by the British archaeologist Sir Austen Henry Layard inside the ruins of the Royal Library at Nineveh in what is now northern Iraq. The library belonged to King Ashurbanipal, an Assyrian ruler who made a habit of collecting and copying documents from earlier civilizations. The physical tablet dates to around 700 BC, but the knowledge on it is much older, believed to be a copy of an original Sumerian record from thousands of years before. For over a century and a half, K.8538 sat in its museum case and gave nothing away. In 2008, a researcher named Mark Hemsel from Bristol University and engineer Alan Bond used software to reconstruct what the ancient night sky looked like on any given date and applied it to this tablet. What they found set off a debate that continues today. But before we get into their findings and the much bigger question hiding behind them, you need to understand who actually made this tablet, because the whole story depends on it. The world's first astronomers. Most people picture ancient astronomy as priests waving incense at stars and inventing stories about gods. The Sumerians and their successors, the Babylonians, were nothing like that. They were running what may genuinely be the longest continuous scientific observation project in all of human history, and they ran it with a level of discipline that is hard to fully appreciate from a modern distance. Starting around 3500 BC, observers in the Tigris and Euphrates River Valley began keeping structured, dated, repeatable records of everything they saw in the sky, organized into archives that later scholars could build on. Their astronomical diaries were kept continuously for over 700 years, recording nightly positions of the moon and planets alongside weather, river levels, and grain prices, because the entire point was finding patterns across time that could be used to predict floods, droughts, and harvests. The Enuma Anu Enlil, a real surviving series of around 70 cuneiform tablets, covered hundreds of celestial observations paired with their predicted consequences, including eclipses, planetary conjunctions, and lunar anomalies. They built this entire framework from scratch, through unaided observation, with no telescopes and no earlier formal scientific framework. They measured angles using the width of a finger held at arm's length for roughly 1 degree of arc and x, a full fist, for 10 degrees. Studies of their eclipse predictions show accuracy within a few minutes of what modern orbital calculations produce, which is the result of centuries of obsessive structured watching, not guesswork. Their sky watchers knew individual stars on sight, calculated planetary positions from mathematical tables, and predicted lunar eclipses months in advance. When something new appeared in the sky, they documented it with everything they had, the exact time, the phase of the moon, the position relative to known stars, and the angular distance from neighboring objects. These were not mystics, but the world's first working scientists, and K.8538 came out of their archive. So what exactly did it record, and why does it keep coming up in conversations about a second moon? A night nobody forgot. When Hempsel and Bond applied their sky reconstruction software to K.8538, they concluded that the tablet was the night diary of a Sumerian astronomer recording what he observed before dawn on June 29, 3123 BC. What the software suggested the scribe was watching that night was not a star, planet, or the moon. It was something crossing the sky at tremendous speed, described in the tablet as a white stone bowl approaching from the northwest. Hempsel and Bond argued the tablet records an asteroid over 1 kilometer wide, tracking across the Mesopotamian sky toward a collision site in the Alps, specifically a location called Kurfürst in Austria. Kurfürst is a real place with a real mystery attached to it. A giant, ancient landslide 5 kilometers wide and 500 meters thick that geologists have debated since the 19th century. Early researchers thought it had the look of an impact zone. Later analysis decided it did not match the standard crater profile. Hempsel and Bond proposed that a high-altitude airburst, an asteroid exploding before making ground contact, would produce exactly that kind of landslide without leaving a classic crater. They calculated that the superheated debris plume would sweep southeast over the Mediterranean, re-entering the lower atmosphere over the Levant and northern Egypt, igniting everything flammable across a wide area below. To be clear, mainstream archaeoastronomers largely read K.8538 as a conventional star chart, not an impact record. Geologists have dated the Kurfürst landslide to around 9000 BC, thousands of years earlier than Hempsel and Bond's proposed date, and that gap has not been convincingly resolved. But here is what makes the tablet genuinely fascinating, regardless of which reading is correct. Whatever the scribe was recording that night, it was clearly something that broke the pattern of routine sky observation. The rumor of a second moon. This is where the story gets interesting and where you have to pay attention to the line between what is claimed and what is confirmed, because that line matters here. Over the years, a number of researchers and writers looking at K.8538 and other ancient Mesopotamian texts have suggested something that mainstream scholarship has not confirmed, but has also not fully dismissed: that ancient sky watchers in Mesopotamia may have observed a secondary celestial body in Earth's orbit at some point in antiquity, something that moved differently from the moon, appeared for a period of months, and then vanished. The claim usually centers on unusual phrases and angular measurements in cuneiform astronomical texts that some interpreters read as describing an object distinct from any known planet or comet. No cuneiform scholar working in the mainstream has verified that reading. The angular measurements in question have alternative explanations, and the texts that supposedly describe a second moon can be, and generally are, read as describing something else entirely. But what is truly interesting here is that the speculation did not come from nowhere. It came from people looking at real astronomical records produced by real precision observers and noticing measurements that seemed hard to account for using only the known objects in the sky. Whether those interpreters were right or wrong about what the measurements mean, the underlying question they were asking turns out to have a scientifically legitimate answer, one that was not available until the 21st century. What modern science actually confirmed? There's something that tends to stop people cold when they first encounter it. Earth has had a second moon, and this information is not derived from mythology or unverified ancient texts, but from confirmed, peer-reviewed, published modern astronomy. We've learned from these published works that Earth has captured temporary natural satellites on multiple documented occasions, and scientists have watched it happen in real time. In September 2006, the Catalina Sky Survey in Arizona detected an object orbiting Earth. Initial analysis suggested it might be spent rocket stage debris since its light spectrum resembled the titanium white paint on old Saturn V boosters. But the way solar radiation pressure was nudging it off its expected path was consistent with a natural rocky body, not a hollow metal tube. The object, named 2006 RH120, turned out to be a small asteroid roughly 2 to 3 meters across that had been gravitationally captured. For about 13 months, from July 2006 to July 2007, it orbited Earth, looping around us 4 times before drifting back into solar orbit. Earth temporarily hosted a second natural satellite. An asteroid called 2020 CD3 spent roughly 2 years in Earth orbit from around 2018 to May 2020. In late 2024, an object called 2024 PT5, likely a fragment blasted off the lunar surface during an ancient impact, was briefly captured for around 2 months. Astrophysicists at Cornell estimated in 2011 that Earth almost always has at least one tiny temporary satellite in orbit at any given moment, mostly too small for current equipment to detect. The average capture lasts around 286 days. The mechanism works through gravitational balance points called Lagrange points, and it is the same process that captures comets around Jupiter. Temporary moons are not rare, but are a normal part of Earth's gravitational life. The only question relevant to our story is what happens when the captured object is not 3 meters across, but large enough that anyone looking up at the sky at night could plainly see it. What ancient eyes would have seen? A captured asteroid a few meters wide is invisible without a telescope. If scaled up to 100 meters in an orbit at roughly lunar distance or closer, it becomes a bright, moving point of light that stands out clearly in the night sky. At 500 meters across, it would be unmistakably prominent. At a kilometer or more, it could rival Venus in brightness on a clear night, depending on how reflective its surface was. But brightness is only part of what would make it strange. The moon follows a predictable path across the sky, rising in the east and setting in the west along the same broad band that the sun and planets travel, called the ecliptic. A captured asteroid with a different orbital period and inclination would cross the sky at an unexpected angle, rise and set at times that matched nothing already in the catalogue, and complete its circuit in a period unlike any known object. It would look fundamentally wrong, like something that had shown up one night and started doing its own thing entirely. For a trained Sumerian skywatcher, that wrongness would be impossible to ignore. Their entire professional purpose was to know every object in the sky and what each one meant. A new, persistent, bright object moving on an unfamiliar path night after night would have no equivalent in any of their existing records, and their response would be exactly what their training demanded: document everything. We know the Babylonians tracked Halley's Comet from 164 BC onward with enough precision that modern astronomers can match those records to the orbital mathematics exactly. A captured asteroid in temporary orbit would be even more trackable than a comet, appearing on a predictable path night after night for months. If Sumerian observers ever witnessed something like this, the record would almost certainly exist somewhere in the archive. When a moon falls apart. A large captured asteroid does not just orbit peacefully and drift away cleanly. The physics of what happens to it is one of the more dramatic processes in the solar system, and understanding it explains the vanishing part of this story. Every planet has a Roche limit, which is the distance inside which a loosely structured object gets pulled apart by the difference in gravity between its near side and its far side. Most near-Earth asteroids are rubble piles, loose collections of rock and gravel held together mostly through their own gravity rather than any rigid internal structure. For a rubble pile, there is a critical distance from Earth, roughly 9,500 kilometers, at which the tidal stretching force exceeds the asteroid's self-gravity, and the object begins to disintegrate. Its pieces spread out along the orbital path and then fall toward the surface as a debris field across a wide area, rather than as a single impactor. This is not theoretical, mind you. Comet Shoemaker-Levy 9 crossed Jupiter's Roche limit in July 1992 and broke into roughly 20 fragments. In 1994, those fragments struck Jupiter one after another over several days, leaving bruises larger than the entire Earth in Jupiter's cloud cover. Astronomers watched every impact in real time. The same physics applies to Earth. A large asteroid in a decaying captured orbit would spiral gradually closer over months, tightening with each pass until it crossed the Roche limit and broke apart. For anyone on the ground underneath that event, the sky would appear to be on fire, with fragments burning across hundreds of kilometers over the course of days. If ancient Sumerian astronomers lived through something like that, the word they reached for would probably not be asteroid. It would be punishment, or omen, or the end of something. What the ancient record hints at. The honest version of the ancient record is not as tidy as some videos would have you believe, but it is still genuinely worth taking seriously. There is no confirmed case of multiple civilizations independently writing about the same second moon in the same year. Anyone telling you that Babylonian, Egyptian, and Chinese texts all line up perfectly on this is filling in the gaps themselves, not reading from the tablets. What the actual record does show is real and strange in its own right. Around 2200 BC, a major climate disruption occurred across a huge stretch of the ancient world all at once. A severe drought and societal collapse hit Mesopotamia, Egypt, and the Indus Valley in roughly the same window of time. The Akkadian Empire, one of the most powerful states in the ancient world, collapsed. Egypt's old kingdom fell apart. Researchers call this the 4.2 kilo-year event, and it is well documented in the archaeological record. Some scientists have wondered whether something from space might have triggered or worsened it, though no one has confirmed that connection yet. What is not in doubt is the physical evidence left behind. Cities that were simply abandoned, supply chains that stopped working, and large groups of people moving away from places they had lived for generations, all around the same time. On top of that, ancient texts from many different cultures describe terrifying events falling from the sky, including fire, large stones raining down across wide areas, rivers running wrong, and entire areas being wiped out. Those descriptions exist in the real record. Whether any of them describe a temporary captured moon falling apart in the sky above is something nobody can confirm right now. But researchers are genuinely still asking the question, and the science behind it is real enough to keep asking. Why this is so hard to prove. There is a whole field of study dedicated to matching ancient sky records to real events, and when it works very well. The clearest example is Halley's Comet. The Babylonians tracked it from 164 BC onward, and when modern astronomers ran the math on those ancient records, the numbers lined up perfectly. No guessing or stretching the evidence, just a clean match between what was written on clay and what the sky was actually doing. That is what a solid case looks like. K.8538 has not reached that level yet, and understanding why is actually pretty interesting. The problem with ancient sky texts is that they mix real observation with religious meaning, cultural symbols, and shorthand that only made sense to the people who wrote it. A phrase that looks like a physical description of something in the sky might actually be a way of saying the gods are angry, or a reference to a story everyone at the time already knew. One scholar reads it one way, another reads it completely differently, and both can make a reasonable argument. When the original writer is 4,000 years gone, and half the reference material that would settle the debate has not survived, you end up with a lot of educated disagreement and not many firm answers. For anyone to convincingly prove that ancient observers recorded a large second moon, they would need to find texts that track the same unfamiliar object over many months, with specific enough position measurements that a modern computer could reconstruct its actual path around Earth. And they would need at least two separate ancient sources describing the same thing independently. Nobody has found that combination yet. But here is what has changed. Now that we know Earth really does capture temporary moons on a regular basis, researchers have a concrete reason to keep looking. The right tablet could already be sitting in a collection somewhere, still waiting. What is up there right now? Earth is not floating in empty, calm space. There are millions of asteroids out there, moving in paths that bring them close to our planet over and over again. And some of those paths bring objects close enough that Earth's gravity grabs them for a while. The confirmed captures we actually detected happened in 2006, around 2018, and in 2024, but those are only the ones our telescopes happened to catch. Scientists at Cornell calculated in 2011 that Earth probably has at least one captured object orbiting it at any given moment, and almost all of them are simply too small and dark for our current equipment to find. Now think about what happens when the object that gets captured is not the size of a car, but the size of a skyscraper, or larger. The same gravitational process that grabbed those tiny rocks works exactly the same way on a much bigger one. Big captures are far rarer, the kind of thing that might happen once every several thousand years, but they are not impossible, and the science says they would work identically. The object would show up in the night sky, visible to anyone who looked up, moving in a way that matched nothing else already there, and it would either drift away eventually or spiral closer and closer until it crossed that danger zone or the Roche limit and broke apart. But detection is still far from complete. Asteroids coming from the direction of the Sun are basically invisible to our ground telescopes until they are already right on top of us. The Chelyabinsk meteor was about 20 meters wide and never reached the ground, yet its shockwave injured over 1,500 people and shattered windows across a vast area. Nobody saw it coming at all. NASA's DART mission in 2022 proved we can nudge an asteroid off its path if we know it is coming. Knowing it is coming is still the part we have not fully solved. The Sumerian astronomers who made K.8538 had none of these tools. What they had was the habit of watching the sky every single night and writing down anything that looked wrong or didn't fit the patterns they were familiar with. That tablet is still in the British Museum right now, and it still has not told us everything it knows. But one question that we must ask is, if a second moon once hung above the Earth, what might be orbiting above us right now that our modern equipment simply cannot see? Leave your answers in the comments below. Don't forget to like the video and subscribe to the channel. Thank you for watching, and if you enjoy this video, please click on the next one on your screen.